Hey, hello everyone. Let
Okay,
me
yes,
just get
hello.
myself all arranged.
All right. So the way today's workshop is going to work, I guess it's a little different, and our plan is a little different than the kind of follow along step by step kind of workshops. This is really more of a crowdsourcing different solutions, so we have interesting things to talk about style workshop. And if everybody kind of joins us also in the Slack, we've posted the link to the repo that will get you started on some of the work we want you guys to try today. I'll post it in the chat here as well for your convenience. But the idea is that we've prepared 4 exercises that show some of the strengths or weaknesses, or hopefully challenge you in some small ways with regards to Clojure and functional programming. And you're only expected to do 1. But if you have time to do more, sure. But in the first hour, we're just going to let you guys work on them. So for you guys who have been doing Clojure for several years, you'll probably find them pretty easy. And if you're brand new to Clojure, then you're either welcome to attempt one of them to the best of your ability, do one of them in another language that you are more comfortable with, and or pair with someone else. And so if you want to find someone to pair with, I recommend doing that on the Slack channel. And so for the other note there, like most of the README goes through and kind of explains each assignment. We're going to be here for the first hour just to help you guys out if you have questions here or in the Slack channel. But sorry, I'm getting lots of information coming in from various places. So we'll be here, but mostly the first, until 11 o'clock, you have a chance to just work on things on your own or with a partner, or chiming in here and asking for help. And then we're going to spend the second hour going over people's solutions and talking about them. And so as you're working through these solutions, the thing that we kind of ask you to attempt to do is kind of, they're kind of toy little examples, but try to think of them as like being as part of a larger project. And they're meant to be small so that you can easily tackle them, but we want you to write code as if it was like production code to the best of your ability, or things that you would be proud of having inside of your code base. What else did I want to point out? Oh, after you're done, we ask that you, like, if you want us to talk about and share and be able to discuss some of the things that you have done, there's a spreadsheet link in the README that talks about where to submit. And so that way later we'll go through and we'll talk about them. And I guess to pick a challenge, so there's four exercises for you to pick from, and in the README as well, we've kind of mentioned, so that we get an even distribution amongst everyone, we ask you to use, there's a little copy paste some code into the Clojure REPL to rand nth decide which one to tackle first. And then if you have time for more, you can do whichever other ones, but as a way of, like, evenly distributing, please do roll the random number and have that decide what you're going to do. Yeah, so the link has been posted. Go ahead and get started and reading. If you want to get a pairing partner, you can coordinate that in Slack. We're going to be here kind of semi-silent for the next hour, and so at 11 o'clock EST, we're going to start kind of chatting about people's solutions and kind of viewing them and seeing what different ways how people approach them differently and what we can learn from that. So any questions from anyone? Either you can post them in Slack or here in the Zoom. Any JDK version? No, I think most of these things are pretty standard. Like the solutions just require plain Clojure. One of them uses some very simple libraries, but like the work has already been done for you. So I think JDK 8 or the latest JDK should work fine. And how are we going to present the solution? So our current plan right now is that you're going to work on it, and then just, you can fork the repo and then push it, and then you will send us a link in the spreadsheet. And then me and James are going to take a look at it with fresh eyes and discuss it. And then we might be able to ask questions of you in the second hour. But you won't have to, for this one, we won't expect everyone to actually be doing the presenting. We're going to be looking at it and then potentially maybe giving you a chance to comment, but it will be mostly kind of me and James kind of code reviewing and taking a look on your behalf. Max asks, what's my favorite of these four? I mean, they're interesting. I tried to, as I was like preparing and looking through tons and tons of different potential katas, I was trying to find things that weren't completely trivial in functional programming or especially challenging. I think for experienced Clojurers, the bowling one might be an interesting little annoyance because it seems trivial and then it isn't. And there's like probably an elegant functional solution in there somewhere, but you have to kind of work for it.
I think the birthday greeting one too is kind of nice because it's working code that you just have to refactor. So that's kind of nice. You can do like a pass of kind of like successive iterations to just keep it functional, but just make it cleaner and cleaner, and kind of practice like isolating state can be fun. The Mars one, the existing OOP solution, is interesting. If you want to see how heinous Clojure code can look like, you might want to have a look at that one just to gawp at what how badly you can write Clojure. So if you look at the before state of that.
Oh, there's a question in the Zoom Q&A. Is there a way to split us through Zoom? And I'm not sure if there's a way that we can do that directly through this this chat, but I know if you guys want, you can set up your own Zoom calls. I know Slack also lets you do one-on-one video calls. So if you ever want to do that for the pairing side of things, that might be a good option.
So I'm just going to share this informational screen in case anybody pops in and joins us midway. But yeah, again, we'll be around if you want to pop in. If you guys need help, you can raise your hand here or in Slack.
We're overwhelmed by ways people can communicate here. You can raise your hand, you can put a message in the chat, in Zoom, you can do a Q&A, you can send a message on Slack.
Yeah, we'll try our best.
Do something, we'll figure it out.
Well, I'll keep an eye out. It's okay.
By the way, folks, I think Alexandra in the Slack is looking for someone to join on doing the bowling problem with. So if you're working on the bowling problem and would like to pair with Alexander, hit him up on the Slack. FYI, folks, we've had a little bit of discussion about the Monty Hall problem and what it expects as output. In general, I mean, there is a test case there, but you don't have to, for that one, you don't have to necessarily meet that test case one exactly. But in case you want to take a look at what we expected, what that test case expects, we have some sample stuff in the Slack.
So looks like it's just about 11 now. So if people are finished or mostly finished, I just want to make sure you get, if you want us to review the stuff, you can put a link to your code in the spreadsheet that's linked in the Slack channel. So you can just put a link in there. It's helpful too if you want to make the link directly to the code, just to make it a little easier to jump right to it. Yeah, and then put your put link to your code in there, and then yes, in a moment or two, we Rafal and I will start going over the solutions and talking
Yeah,
about them.
perhaps. I mean, do we want to? Do people want another like maybe 10 minutes? Like if you're working on something and you think you're kind of close, maybe message and so you know what? I'll like 1 to 10 minutes.
Apparently, there is an ability to do a poll, but it's not trivial.
Yeah, we can do the poll, but I believe Nicola has to set that up separately since for some reason it's not built into the app.
I guess raise your hand or
yeah, or just react to Raf's post on Slack. Do like thumbs or sure, raised hands for you want 10 minutes more, or I don't know,
or just
eyeballs for you want to go now.
Okay, so we've got a few.
And I'm also just going to step away for a moment.
Okay, okay. Sure, we have a few people asking for a little bit more time, so that's fine. Go ahead. Don't stress out. I'll take your time. I know some of those problems are a bit hairier for some of you guys, and so no worries. Cool. We'll check in again in another 10. All right, everyone. We're gonna get started with doing some of the reviews. We'll definitely get started with the birthday greetings because a number of people were able to do that. That one was definitely probably one of the easier ones. For those of you who are still working on stuff, if you want to keep working, you can always come, since we're recording this, you can listen through the reviews later, or you could, maybe commit and show us what you have. It's certainly, we have, James did prepare some solutions, but I'm sure would be interested, even if you don't have a complete solution, if you were to commit and push and share what you have in the spreadsheet over the next minute or two, that would still be valuable, and I think we'd be able to get something out of looking at the partial solutions. So especially for Bowling Score and Monty Hall. Cool. Alrighty. So yeah, let's get started. I'm gonna share my screen, and then James, I guess you can.
Yeah, I was wondering, Raf, do you want to maybe talk about some general things about the solutions before we start looking at specific ones? Or?
I think we can go one by, well, I was going to introduce each problem for those because I'm sure not everyone read every single problem, and then we can talk about some of the challenges in that problem, and yeah, so let's aim to spend, I guess, like 10-ish minutes on each problem. Sure, so let me share my screen once I figure out where that is, and then we can discuss what we see here. Okay, so you're able to see the the GitHub now in the browser.
Mm-hmm.
Okay, so let's talk about the birthday greeting service. So in this one, you were tasked with, you were given some code that already basically took some things out of a CSV, and for every kind of person in that CSV whose birthday matched today's date, in terms of like the month and day, they were sent an email. And so the existing code was just one function with a threading macro, just kind of reading the data, parsing it, filtering it for the people whose birthday it is today, and then just sending the email. And of course, this kind of solution for quick things would be fine, but the hope with this one was to kind of see like how could you actually break this up into and make it so that it's possible to test. Because right now this is a very stateful piece of code. The kind of three things that are kind of make it kind of trickier to test is one, it's depending on some external file. And so everything downstream of that just assumes things around the structure of the file. Number two is the current date is another kind of stateful input into the function, and that can make it tricky to test reliably. And so hopefully some people figured out that we probably want a function that takes in 2 dates or something like that, so that it's somewhat testable. And then of course, actually sending the email is something that is somewhat tricky to test. There are some tools actually that we've been using lately where you can run like a local SMTP server and have it just like pop up and show you like the emails you're sending, which has been useful for like testing templates without just actually sending an email. But anyway, this is kind of what we were given. And so let's kind of take a look at how people kind of might have broken it up and if they wrote any tests. So we're going to kind of, we might not be able to go through everyone's solutions. So we'll probably do is like look at 1 or 2. And then if somebody has like a particularly different solution that they want us to look at, we'll take a look at that. So perhaps let's start with Alexander's, and let me just copy that link. So let's take a look. Okay, so we have, we see that kind of Alexander has broken up the code into a few different functions. So we still have our greet here, which takes the CSV. There's a load CSV now and a whole bunch of now helpers, where as opposed to before there was only one. So let's kind of see how things are going here. So the load CSV basically just loads all the rows and columns. And so like basically given the path, it will just return the rows and columns. The filterer assumes a bit. So the filter birthday today is broken out. It could be, I guess, yeah, part of me thinks about whether, if I was being like really trying to test this, whether there was a way to like be able to like mock out today's date or something like that. But
yeah, I think the one kind of the 2 issues I see potentially with the way that this one is that, as you say, like one, it depends on the current date. So if you want to write tests for birthday today, it's kind of awkward. You need to somehow mock out what local date now does. Like there are tools for messing with the clock, but it's much simpler if you just give it a particular day and just say, are these 2 dates on the same day? And then also we note that this function is still, it's keeping it just like in the row or in the column order that this was loaded from the CSV. It's still keeping them as just vectors where whatever the order is, the first thing is the name, and then the second thing is the email, and then the third thing is the date. And so this function is just assuming that the date, like the argument's always a vector, date's always the third thing. So it might be nice. So some potential other ways is, one, make this function just take a date string and then a date to compare it against, or potentially parsing the rows into a map of some sort, I think can make it easier to deal with later on, just when you have things that you can actually identify by name instead of just by position.
yeah, but the core of like extracting things into multiple functions that could then actually be in theory tested. Let's see, do we have any tests? I mean, not that it was like fully mandatory. I'm just curious if no, that's fine. And again, making things testable really, like I find that trying to do things in a functional way and trying to like optimize for like pure functions naturally makes things much easier to test. So yeah, I guess the other thing I was comment about, one thing that I've occasionally also found useful when doing things for emails, like definitely having something like this where you've taken some parameters. We kind of mentioned that maybe these should be maps with keywords rather than just an ordered vector. It tends to be kind of more easier to pass around data if it's in kind of map form and compose it. but occasionally this could also be split out into a separate piece or done with hiccup or something. I don't know. But this in general is that, you know, it is a pure function, so that's easy to test. This thing is not, but that's kind of understandable. If we were trying to be like an alternative potential thing for this kind of issue is like when you're using, let's say, like an email system or a database or whatever, is like there's also like chance to potentially do a dependency injection into these kinds of functions where like send message would receive some parameter as an object that would represent the function for sending. And in the testing case, all it does is like prints, and in the production case, it's the actual email sending function, but they both follow the same API. But in Clojure also, like, you know, for these sorts of things in Clojure, if you're testing them, it's possible to, instead of doing that when in your functions, you could also just use
like with redefs.
With redefs. So you can just like locally kind of redefine a function when you're running a test. And that in practice kind of works out. And I feel like that's one of the reasons why in Clojure we have less of the kind of mocking stubbing libraries, because with redefs kind of gets you 90% of the way there.
I believe Alexander also did the bonus for sending on the same.
Sure, we can take a look at that.
Same day. Oh, I was going to say though, I think maybe we should just, in the interest of time, just go through the other solutions, and then if time allows, come back to look at the bonus one.
Okay, sure. Yeah, so let's take another one. Let's take a look at a one from maybe, let's see, Wesley. So we've got some code and a shameful tests. All right. Let's see if there's anything. And if anyone of those folks that have been done the birthday greeting and you've done it in a very, very different way, or something that you want to highlight, then go ahead and message us in Slack or in the Zoom right now, and then we'll try to make sure that we spend a moment looking over it. All right, so looking at Wesley's here, we'll kind of start at the bottom. So we have something that we're getting like loading employees, which presumably is, sorry, load employees. Where is that coming from? That's over here. It does some of the reading of the CSV, and it's doing this zip map trick to apply the headers of the CSV to each item. So now we're, instead of getting back a vector for each row, we're getting back maps. And then he's also immediately in here parsing the date, which can be nice. So then instead now we're basically getting employees are these, it's going to be a list of map objects. This is the only thing I would say, like, you know, that might make this more reasonable to test is whether you put the file that the file would probably be an input to here rather than being hard coded here. But that's a forgivable given this is the amount of time that the time pressure. Here also, so two greetings I see is kind of nice because it's taking in today and employees. So from this point of view here, it makes it somewhat easier to test because this looks pure. So I like that. And get today presumably is kind of trivial. I mean, I don't know if you really need to make that a function of its own. Probably would have been sufficient to just have it passed in, like just have it written here. But and so we look at two greetings, the emails, format email here also takes in today, which is nice. So this should be reasonably testable. And I think Wesley did include some things that are what he calls some shameful tests. So let's take a look at that. And there are some, I guess his solution might have worked with the extension, which was like handling leap years, but we're gonna kind of not go over that right now. But at least it seems somewhat possible to test the various components. I'm not going to go too deep on this, but I guess what I look for usually is, yeah, like testability in functional programming languages usually equates to like pure functions. Like this is easy to test. This is easy to test. Yeah, this is easy to test. This one's a bit harder because you have to give it a CSV file, but it could be made somewhat reasonable, even if this was just receiving like this was like a parse employees out of CSV, and
yeah, especially this function is still like it's fairly trivial in terms of what it does. It could pull like that inner loop out into something else, but yeah, I think this is like a very common way of dealing with CSVs, like a very common pattern of you take the first row as the headers, and then you zip map it with the rest of the data. Also note that doing the zip, basically giving 3 arguments to map, where it just cycles, it just repeats the headers. So then it just like repeatedly will zip map the things in data together, which is a nice trick. Usually I do this by doing like map, and then the function I map is like partial zip map headers, but this is a nice way to avoid having to do a partial. I'm just doing multiple arguments, like multiple lists to map.
Yeah.
It's a nice trick.
Cool. Anyone else anyone else want to point out anything or something that like you want us to review your birthday in particular? Send a message now. Okay. If we have time, maybe we'll come back, but we'll kind of give some chance to look at some of the other ones. I know Wesley, you made some comments about like, oh yes, why you made this a function to make it easier in some places about whether or not things can be passed as functions, and I guess that's true that in some places that it can be annoying.
It's easier if you need to make this work in like Clojure script. Now you have one function that you just like conditionally do different things in.
Okay, so let's.
Do you want to look at maybe one of the bowling score solutions that has?
Sure, we'll take a look at bowling score. Let's.
It's a tricky one.
Sure. So let's first, I guess, let me pull up the bowling score problem, and we'll talk about it briefly. So in the bowling score exercise, basically you were just asked to write a function that, given all the rolls and the results of the rolls in a game of bowling, what was the total score at the end of the game? And that seems somewhat trivial, but the tricky bit with bowling is that the score on a given frame actually depends on future rolls. So like if you get a strike, then so for example, if you knock down all the pins on like your first frame, then your score for that frame is going to be 10 plus anything that you roll in the next 2 rolls. So there's this, so it's a bit stateful, and it's like looking ahead stateful, which is particularly annoying sometimes to do.
Especially because it's not necessarily just in the next frame, because it means if you also get a strike in the next frame, there's only 1 roll in that frame, so you have to go ahead.
But there might have been 2, if you had gotten a spare in that frame, then you would have had 2 rolls. So yeah, it's a little nasty. It almost makes, and I hadn't realized this when I was first looking at it, because you know most bowling alleys do the scoring for you, and I was kind of surprised at.
One of the things I think ended up being subtly the nastiest is those subsequent rules for the bonus rolls. For if you get a spare or a strike in the last frame, you get these bonus rolls, and it is not especially explicit here, but those don't get scored on their own. From what I understand from looking at
those are just
score, they just get added to the that final frame. Like you just roll them in terms of adding to the score, but they don't get scored on their own. So depending on how you structure your code, you kind of have to especially handle potential, like you have to basically know if something's a bonus roll or not in terms of determining are you going to treat it specially?
Yeah,
Which can
depending.
be
I think that depends on
challenging.
your approach to the solution. Yeah, you might have. Yeah, you'll probably have to special case something of those bonuses. Now, of course, the input that we give you is not, you know, and we created a bunch of tests. Hopefully, there were no bugs in these tests.
There was one, I think, but it should
the
be
other day.
fixed.
Okay. And you know, perhaps, you know, just looking at this, like, it's perhaps not the most amenable to the most amenable like way of representing this data, because it completely kind of hides what frames there are, because like you basically take turns at bowling, right, and you get up to 1 or 2 rolls per turn. And so one of the first things when I was thinking of this, the solution was to take this input and first transform it, and potentially by like adding another layer of vectors for each frame. So there'd be like, for this where I rolled 10, 3, 4, blah, 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 there would be a vector around 10, because that was a single frame with a strike, and then another vector around 3, 4. And then these 2 zeros would be paired up, these 2 zeros would be paired up, because that's how the frames would work. And then at the end, maybe you would pair up because when you have those bonus rolls here, for example, this 10, by rolling a strike at the end, you get 2 bonus rolls. These ones would technically count as a single frame as well. So that was my thinking, is that if you'd first do a first pass of converting things to frames, and then counting the scores would be hopefully somewhat easier. But let's take a look at what people did. I don't know, let's grab randomly. I'm going to grab Diego's here, Diego and Alez. Hopefully that's that okay. Let's take a look.
Yeah, so I'm looking through that one. So that one's interesting. It's using records to store. Yeah,
So we have
roll just has
4.
some helpers that's checking whether something to strike or spare.
I'm going to go back and we have roll. Okay, so just taking a quick look at roll, because it's like some helper function where we have some function to help determine whether something is a strike and whether something is a spare, given 2 rolls. So when we see strike and spare, that will be useful, just to know that those exist. Cool. So yeah, we have some frames. We're kind of just first like scan through the code. We have some, yeah, being able to convert rolls to frames. So this is presumably doing that transformation that I talked about. And this can be a reducer. So let's kind of see, starting from the bottom here. So we have some accumulator, right? And so the idea is that we're using some reduce to, I guess we're taking rolls, we're going to convert them to frames, and we'll take a look at how that was done. And then we have some accumulator record, which could be a record, I guess. It'd be interesting to hear, like, I would also, this could probably have been a map as well, or something like that, but cool, records. And we then have some reducer that is going over these things. So let's take a look at rolls to frames and how that was maybe implemented here. So in rolls to frames, we're kind of doing a loop, which is kind of like a recursive, effectively a way of doing, it's some syntax sugar for effectively doing like recursion, tail recursion. And given all the rolls, we start off by extracting like the first roll, the second roll, and the remaining. So that's, we're just doing the destructuring here. And then we use some of those conditionals to check, okay, if it's a strike, then we're presumably going to recur with a few less things. And we're kind of updating
yeah, so it's making a new frame that represents that. Presumably that should be, the number should be switched. I think as we review the code too, and the authors, feel free to chime in, like either raise your hand or drop stuff in the chat. This is still in progress. It explodes. The tests give null pointer exceptions, I believe. when running the tests on this one. I believe that's coming down to when it's checking if it's a spare. Because essentially one of the kind of annoying edge conditions is that there's not necessarily an even number of rolls. So it's possible that second roll is nil. So that check for spare, because it adds the two things together. If second roll is nil, then this will explode.
That's
One of the things that's kind of tricky about this, there's a lot of little edge cases.
Now there wasn't. I'm gonna try to. There was a. I have
Stuart
to pull
Holiday
it up,
one?
but the Stu
Yeah,
Holloway.
I'll send you that link when you find it.
Sure. There are some elegant ways to do some of these things. But yeah, in terms of the approach, I think like definitely trying to parse out the roles to frames is important. And then when we do, and doing a loop is a reasonable way of doing that. I think, I mean, personally, I don't use records much. We just typically use maps to represent various data that we might be passing around. But I think, you know, this is fine. It's just, I guess our preference is usually just to do maps. And when we do the reductions, that's going to be given a bunch of frames. And okay, and so you're calling first frame to be like basically that accumulator frame, and then the second frame to be the next one. Another approach that I thought that I had in mind when doing this kind of thing with this reduction is you could also do, instead of a reduction, you can do something with partitions. So the partition function lets you, for example, you would, given let's say a list of frames, you could say, give me the first frame and the next two, and then the second frame and its next two, and the third frame and the next two. So there might be, if you haven't heard of partition before, check it out on Clojure docs, and there might be a solution here that might be nicer using partition. I don't know, but basically, like a partition lets you, for example, given a list of numbers, take like the way that I was thinking of using it would be something like.
I mean, if you want to pull up like the example
like,
solution that I did does like partition 3.1, where you can say partition by a certain amount. So partition with just the one argument will group the list into that many things. But if you get this second option is a step. So like this example here, it's going 3 things at a time, but only moving down by 1. So that's a nice way. It gives you this kind of sliding window to see the current thing you're looking at, and then the next 2 things that you're going to see. Yeah, as Alfonso's saying in the chat there, that yeah, they thought about using partition. Yeah, it's challenging because sometimes they would have 2 and then sometimes 3. Yeah. Right. Yeah, and then there's also partition all. Yeah, I believe you can also actually, yeah, there's an optional another optional argument partition, which is the pad, but that does do something slightly different because it'll only pad of the last collection. So I found
something that might work.
Yeah, I realized actually, yeah, the way I did it, partition all, I think would have done it.
So let's take a look at. We'll take a look at James's approach. Wait, this was Rover's. I
this
accidentally grabbed the wrong one.
Yeah, I mean, mine is definitely not the best way of doing it. I think the code there, the first one is just like one giant ugly loop that does it, and then the second one is kind of this more functional.
So we kind of looking at this solution. Yeah, so this uses the loop construct as well, but it is a pretty.
It's basically extremely imperative, like the way it's doing it.
Pretty heinous, but at least it shows that like Clojure, like the loop, does allow for doing things that like you might want to do in imperative language, and for certain things like this, which are particularly stateful, sometimes that's what you got to reach for. But there are certainly sometimes nicer ways of doing it. But yeah, James here, kind of just like in a single thing, you know, for sure that it might be better to like have some helper functions to like kind of self-document what some of these things mean. But we'll kind of share all these solutions later for you guys if you want to take a look and kind of, you know, think through why and how is this working. But basically, I think you're effectively using the loop as a way of manually creating that moving window directly through the roles, because you have like roll 1, roll 2, and the next. But looking at your kind of alternative solution here,
yeah, so it uses that loop kind of because it was awkward to do the partition, and so that first function up top there is the rolls to frames, and that builds because we have these variable width frames where some frames just have one element, some things have two. So this is building a list of either 1 or 2 element vectors. And then this function frame score. So here, this is where it's using the partition to have like look ahead, where you're given this current frame and then the 2 frames that follow it. Because like basically in the case, if you had 3 strikes in a row or 3 or more strikes in a row, to score that first frame with this first strike, you need to look at the next 2 frames if they're also strikes.
yeah, and so you know that within 2 frames you will definitely get you will get what you need. You will definitely get the 2 rolls if you need them. Yeah. So I like the separation of like figuring out the rolls to frames first. Kind of how I talked about like adding in the vectors, and then in here, then once you kind of have those frames and being able to look ahead, I see you're basically like using Concat to effectively flatten, reflatten. So like we put them into frames so that it's easier to kind of loop over, but then within this calculation, we need to kind of flatten it out because we only want like 2 of the future rolls out of those 2 frames. Those 2 frames might have like 4 rolls or anywhere from like 2 to 4 rolls in them. But yeah, it's kind of pretty reasonable. Then we just kind of reduce plus. And how did you deal in this case with any of the tricky stuff at the end? Is it just by doing effectively this bit here?
I realized I could have just done take 10, but it does map index vector to keep the frame number, and then take while. I don't know, now that I'm looking at this, I don't know why I did that map index vector and then take while, because that is exactly the same as just doing take 10. That's what I should have done there.
Okay. Yeah.
But yeah, you just need to only look at the first 10 frames because the other ones are bonus, but the partition by taking care of this now.
It will handle it. Yeah. Cool. So that's a little simplification you can make to push there. And why do you, and the map indexed.
Like I say, that map indexed and then take while and then second is because, I don't know, I was losing my mind at this point, I think. And I know we just want to get, basically only count the first 10 frames because potentially have bonus frames at the end. And you don't want those. And I don't know why I did it that way. Now that I'm looking at it.
Yeah. Cool. So Frank mentions that looped concat can result in a stack overflow error. So actually, can you further explain that? I don't know. I guess maybe give Frank the mic if you're willing, or someone else that knows, because I want to kind of get a better understanding of what that means.
Hey, just because concat is lazy, so if you concat something that's already concated together, it consumes a stack frame. So if you concat repeatedly upon the same sequence and then realize it all at once, then it can blow the stack. So yeah, it's typically better to use into, although then you have to think about whether you're working with a list or a vector and the implications of that. So
have an undeterminate amount of like potential length of stuff. So like you're commenting kind of here. So here it's not, like in this case, it's not being an issue, but if you used concat inside of a loop, it would cause a problem potentially.
yeah, exactly.
Yeah, because it ends up building like a chain of thunks essentially that you just end up evaluating all at once.
Thank you.
Yeah.
I'm sure that was fun to run into. You know because you've learned by pain. Yeah.
Yes.
Yeah. Cool. Anybody? You know, well, we're gonna go and perhaps take a look at the Mars rover next, just because we're getting kind of short on time. So the rover. So the setup of this one is basically, I mean, there's some code for like, there's these rovers on this rectangle, and you have to just kind of follow a little bit of like very basic logic of them being able to kind of walk around. And we kind of already gave either some, you know, Ruby or Clojure object-oriented code. The Ruby stuff is pretty reasonable. Actually, let me just, perhaps it's easier to link to the Google Doc there. But basically, and this solution I actually based off of a legitimate person's solution in Java, but then I kind of just like made it into Ruby because that way there was way less typing syntax to have to read through. But the kind of setup is that like you might have a rover, and then it has like a plateau that and a direction and coordinates, and some of these things are also stateful. And so you basically have a rover talking to some class that corresponds to like direction that can rotate, so directions can like turn, and plateau has some helpers to deal with stuff, and vectors also you can kind of mutate in some ways. And if you feel like it, and if you looked at my talk last year, we could go, I mean, I'm not going to go through it now because we're kind of short on time, but basically one of the, you know, this is kind of a go-to approach for, I guess, a lot of object-oriented people, is where they like create a lot of stateful objects. And so, for example, you know, vector and direction here, with the way that it's implemented, one of these robots might have, or one of these rovers has a reference to this other direction object that it itself is stateful, and it, you know, sends messages to that direction to mutate itself, and the vector to mutate itself. And I think that, you know, and that could get kind of annoying. And if you guys look through this, you might have noticed that we did something like incredibly heinous. Like if all you have are stateful things, it's really hard to do things like, oh, do this, but only if it doesn't result in some situation. So like, for example, one of the situations that happens in this problem is don't move if that move is going to put you past the plateau. And that and that ends up being kind of tricky and weird, and we had to end up basically creating a new vector object, mutating it, and then checking that vector object and replacing. It was ugly. There's using pure, like, and I think a bunch of OO people have like in some languages, the ecosystems have started to also move towards using objects really just as like pure data structures, and then trying as much as possible to not mutate them and only use objects as basically as a way of typing things. In Clojure, we tend to instead just use plain maps for that kind of purpose. In type languages, you know, I get that, you know, there is value in doing that, or from their point of view, but it's definitely, like, from my perspective, there's a shift in culture around how OO is done, where you try to use more kind of non-stateful objects. And this solution here, even if you were trying to keep it in Ruby, I recommend, if anybody wants to do it, like refactor this so that these helper things are non-stateful, and that all the stateful stuff is being done in the rover. But yeah, right now, like, the initial solution here is a mess of like multiple stateful things talking to each other and trying to coordinate between themselves. Let's take a quick look at the James's object-oriented solution, which, as I mentioned, I think my joke is, Rich Hickey, please forgive us, for we have sinned.
Yeah, this is more just like, can we do this in an OO way in Clojure? Let's see how bad we can make this look.
We're not gonna spend much time. I think it's more to show that because Clojure sits on top of Java, and Java is very object-oriented, Clojure needs to, or is designed to have the abilities to, in theory, be able to do pretty much anything that can be done in Java. and be able to like richly interface with Java. And a lot of Java APIs require you to pass objects and do things as a way of interacting with them. So I feel like this is why Clojure had that has that ability to like basically create protocols and instantiate objects from them and things like that. But like I was looking at this code, James, when you had finished it, and I just like, I can't read this. Like it's Clojure, but it just like my brain does not parse the what this stuff means, because it's so rare to actually be doing like protocols and types. And sometimes certain libraries definitely do that, and definitely ones that tend to interface a lot with like JavaScript or Java. But for those advanced kind of Clojures out there, I do encourage you to try to read through this and get an understanding of it. But let's kind of look at someone's actual solution. So we have Scott, I'll grab Scott's solution and we'll take a look at his approach for a more functional approach to this Rover problem. And okay, let me just, one of us has a whine on our microphone, so let me just check if, sorry guys, just pause briefly, just making sure my input is correct. James, can you check that your input mic is using the correct one? I guess we have multiple ones. Okay, so just as a question, the question for Scott, is this complete or is it just off the top of my head? But anyway, we'll kind of take a look at the attempt here. So the Rover's kind of the go function receives, and we can take a quick look at the tests, sorry. From the Clojure API that we designed is that you're implementing this go function that receives some Rovers that have a position, which is represented by like 2 coordinates and a direction, and then the input is here. It receives a plateau, which gives you kind of effectively the width and the height, and the position of 1 or more or no Rovers, and then you're tasked to basically take the commands. Did I miss out on the commands in some of these? Oh, okay, some of them have instructions, right, sorry. So this is more of a full test. So each Rover has a set of instructions like move, 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 turn right, move, 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 rotate right, move, 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 blah, blah, blah. And you kind of just have to like navigate around and potentially like bump into the edges of the plateau that we've defined. So it's reasonably simple, but the go-to solution in a lot of languages would be just to do it statefully. So let's kind of see how this might be done in Clojure. So we see Scott here is effectively, destructuring the plateau and the Rovers out of that initial map. And the solution is to, again, return Rovers with each of their locations. And what I'm seeing here is he basically takes the existing Rovers and he has a function called move Rover that takes a plateau and a single Rover, and he's basically mapping the move Rover function with the required arguments over the existing Rovers. And that's quite nice. You're basically just like mapping over them. With the kind of setup of this question, the Rovers don't actually interact with each other, so this is a reasonable way to do it. Let's take a look at move Rover. That takes a plateau, and he's destructuring the position and the instructions out of the Rover object. Sometimes I find it's still nice to like put like an as Rover for documentation purposes, just to kind of document what's being passed around. But that's just like occasionally in larger systems it's useful. Basically like creating parameters, like defining parameters even if they're not being necessarily used as a way of documentation. But anyway, then this returns basically the resulting position of the Rover, which he calculates by reducing over the instructions with the initial position of the rover, and using this run instruction function to do the calculation. And so this is, again, I like this nice way of reducing. It's basically, we're taking this, doing reduce is effectively kind of doing a bit of a, like, it's equivalent to in a lot of imperative languages, like a loop that modifies some accumulator, but it's done in a slightly more pure way, without like a variable that can arbitrarily be changed. So we're basically taking this position from its initial value and using reduce and each instruction and kind of modifying position by using run instruction. So I kind of like that. And so then the meat of it is in the logic of run instruction, where, yeah, we're destructuring the plateau X, plateau Y. The second one is going to be the existing position where we're ignoring the X and the Y here, but we're taking the heading, and then presumably we're using the entire position in some place. And then we have the one single instruction. And in some cases, I find, when I do reduce, this might be an anonymous function, but again, it's also often, if it's more complex like this, it's useful to bust it out into its own thing. So what are we doing here? Basically, the logic is if the instruction is move, then we're going to do something. Otherwise, we're just updating that second argument in position. I could see sometimes another way of potentially doing that is just to like rewrite it. I can't edit this, but I could see sometimes it also, instead of like updating, you can also just like create a new vector. Sometimes it's clear that way, but what you're doing here is not wrong. But sometimes for clarity, I like to just be like, oh yeah, okay, we do have X and Y in heading, and we're just saying the new position is square bracket X, Y, and then this value. So instead of updating, we're just recreating. But it's just like,
sorry, I want to say it's the break now. So if people want to go, you can do that. We might just kind of maybe finish talking.
Yeah, we'll continue on for a few more minutes. But
people,
so you're welcome
feel free
to disconnect, and then join us after the break for the next one, where we'll be talking about data-driven domain-specific languages. But yeah, we'll keep going here just to like finish up looking at some of this code. We'll take a quick look at Monty Hall, and then we'll be done. Cool. So yeah, we have basically the two cases of whether it's moving or whether it's just kind of rotating. I like how you basically have a turn left and a turn right that you've implemented as a map, because maps can be used as functions. So you're passing, like, update expects a function to mutate things. And maps are valid functions in Clojure, and they're kind of like simpler because like they're just like a limited domain function. And then I see that you even were quite nifty way of instead of just hard coding left and right, you use map invert to figure out to kind of derive the opposite. So I quite like that as well. Yeah, nice use of case there. And then in the case of the heading, you're basically using a bound function here to update the position only like given the case of the heading. So yeah, I quite like this solution. Nice use of the bound. Nice use of partials. Like some of it, like definitely for people who are new to Clojure, the use of partial and like comp can sometimes, and update, like it takes a little bit to get used to, but I think this is a pretty nice solution to this problem without too much over engineering. And in the interest of time, I'm going to move on to the Monty Hall, and we'll take a look at the setup for the problem. And let me just jump to one of the. And so for the Monty Hall problem, the setup basically is that we want to prove whether or not in this game show setup where they show you basically there's 3 doors. Behind one of them is a car. Behind 2 of them in the show there's a goat. So it's basically one door you win, 2 doors you lose. You get to choose one door, and then no matter which, you choose some door, and then the host is going to reveal what's behind one of the other doors. And he's always going to reveal a goat, because like no matter what you choose, even if you've chosen a car, your door has a car or a goat behind it, there's always going to be at least one other door that has a goat. And so they reveal that one, and then the question is, should you switch or should you not? And this was kind of this problem occasionally comes up in the media, and people kind of argue about it, but it does have like a kind of a correct statistical answer as far as people are concerned. But using simulation is often a fun way of doing these sorts of things, rather than trying to work out the statistics, because like a lot of mathematicians have argued about it, because it's a little tricky to do statistically, but doing it simulationally is usually somewhat trivial. So the idea was to basically simulate the 2 scenarios of like, you would randomly generate a scenario with something being hidden behind one of the 3 doors. You then choose one of those doors randomly, and then in one scenario you would stick with that choice, and how many times would you be correct? And in the other scenario, you would choose one of the other doors. Well, you would choose, you would switch to the one other door. And so the task was to kind of just set up the simulation for that, and then be able to determine like what are the odds. And what we should be seeing based on the kind of literature is that if you switch doors, you should win about 2/3 of the time. But if you stick with your original choice, you should win about 1/3 of the time. So let's take a look at Ming-Mei's solution. And we chose this one because this is a particularly stateful solution as well. It's not, perhaps depending on how you approach it, and I could see like my initial thinking would be like, okay, I will just have some atoms that store all these different like 1,000 iterations in something, and we'll store them in an atom. Maybe you could use reduce. I don't know. Let's take a look. All right, so here's Ming-Mei's work, and this might be sufficient. Can you just, if you're here still, can you chime in on whether or not this is working, or like if it's complete or not? But I'm going to assume it is. Yeah, Ming-Mei says yes, he believes it's working. Oh, but you don't have tests to prove that it is. Anyway, let's take a look. The simulate function is taking in a parameter n, which presumably, looking at this, basically determines how many simulations to run. So this would be like simulate 1,000 times or simulate 100 times. And we set up first by, oh no, this simulate, I'm guessing would be the amount of doors, right? Because we're taking a certain amount.
I think that's the number of iterations.
Oh, that is number of iterations.
Because then it's repeatedly, so it's basically, it's making an infinite sequence of random ints between 0 and 2.
Okay, and so that's to the setup of like which door actually has the prize behind it.
It's generating an infinite sequence of which door, or no, I think that's the door that the people choose. Because we're saying here, the setup is that like basically door 2 is always the right answer. We have the def doors up above. And so then it's just taking the first like n guesses.
Right, okay. So one of the things, I guess, to make this perhaps a more robust, like a simulation that people would not debate, is whether like, this could also be set up randomly. But anyway, that's a.
I think you can show that it's like isomorphic, right? Because it's a matter of just labeling the doors.
Yeah. But okay, so then we basically, given this list of, let's say 1,000 choices, we're doing a reduction where we start off with stay and switch, and these are presumably like the success numbers, like how many times things are successful. and that's a reasonable output. We kind of mentioned, like, in our test that we set up, we kind of had both the true and the false coming, but it's sufficient, I guess, just to show how many of the times it succeeds. And so let's figure out this strategy here. So we have kind of the accumulator, which starts out as this, and then the single choice that they've made. And so if they had, in that case, in the case that they stay, we add whether or not the door, one, whether or not the door was successful or not. And in the case that they switch, we do a little bit of work to figure out how to get the corresponding.
Yeah, so it's saying, like, remove the door that they chose, and then pick the last one of the remaining, because, as I say, like, the one, the last one is going to be the one that they're going to switch to.
Yeah. So,
although I think that does assume that it's an ordered map.
Yeah,
which
like, at a glance, looking at this code, the only thing, like, I would have potentially liked to have seen a bit more clarity around the steps that would have been happening in that simulation. So things like, because this is kind of hiding slightly that, like, which door the host is choosing, which door and then how we're and then which door the contestant is choosing, and we're kind of like actually we're using the same situations, I guess, for, I mean, that's fine. In my head, I was thinking we would just like run 1,000 for one case and 1,000 for the other case. But in what you've done here, which is fine, I think, probably, to just use the same 1,000 kind of situations that you've chosen of choices and do it. But yeah, that works. Let's maybe take a look as the last thing, and then we'll end off for today. We'll take a look at James's solution as potentially to contrast this one. That is not the link. That is just text. So James, perhaps you want to, what is going on? Copy link. Yeah, James, do you want to maybe talk?
Yeah, sure. So kind of the general idea is that, kind of as Raf was saying, I had the idea where, I mean, so I guess maybe starting with simulate strategy, because simulate just calls it twice, where that's given the strategy, which is going to be a function, and then just 1,000 times simulates it once. And then so simulate one simulates like one run with a given strategy. It's going to return true if they won and false if they lost, like, so, if they picked the wrong door. So similar idea where we have a vector, essentially I'm just using keywords to represent the doors. We just randomly determine which door the correct answer is. And then, as I was saying, I think we can assume that the person picked the first, like, door one, because really it's just a labeling question, and we can, like, basically say that whichever door they picked, we're going to call one. And then so the door that's revealed is going to be a door. So I'm using like remove set. So basically it's going to be the door that's revealed is always going to be the door that's not the one they chose, and it's not the one that's the answer. So we say that that's the revealed one. So then the remaining door is the door that isn't the one that was revealed and isn't the one that you picked. And then we just call it the strategy function, where we say this is one we picked and this is the other door, and the strategy function will just return one or the other. And then we just check, is that one that we picked equal to that random answer? And then up above it, we see the two strategies, which are extremely simple. The stay with original just always returns the first argument. Switch door always returns the second argument. So we simulate this a bunch. And then these just return a bunch of trues or falses. And then to count them up, I just use group by. So because they're all true or false. And so then the trues are the time it was correct. The falses are the time that they were wrong. And then I just turn this into a map where the key true is the number of times that they got it right. The key false is the number of times they got it wrong.
I think here you could have used just this effectively could have just been frequencies.
Yeah.
Yeah. So this group by map,
is.
I believe we could have just used frequencies, which is a function
Frequencies just never comes to top of mind for me, I guess.
Yeah, I know. But it's a neat function in Clojure where you can just like given a list of things and you call frequencies on it, it will give you a map of a thing and how many times it occurs, and the other thing and how many times it occurs. So that basically these three things can just be replaced by frequencies. Yeah, cool. I like the kind of, there's this neat idea of like basically having these strategies that can be passed in so that a given simulation takes in some strategy. I mean, I think that like, yeah, I could, in my head, I would have maybe even simulated this, but I see the argument for the label, calling it a labeling problem, but I can also then see, you know, people being grumble, grumble, grumble. Is it really? Prove it to me. But at the same time, yeah, that's kind of neat. And then some other things to just like help report this. And so from a functional point of view, it's trying to think of like, okay, like this, you know, by splitting it up like this, it's at least somewhat then possible to like test for a given, you know, setup. Is a strategy doing what it's doing? You're kind of sometimes trying to like split things apart so that you can be somewhat confident that each given component is working. And then when they're integrated together, sometimes like hopefully when you do the integration, if it's stateful or harder to test, at least the code is obvious. Like for example, this part here, if all it was basically, you know, this could have actually probably been like repeatedly simulate one, like repeatedly do this 1,000 times and then count frequencies. And so this function could have probably been like even simpler to parse and read, even though this is kind of somewhat the one that seems kind of more tricky to test. But yeah, I think the kind of principle of, you know, break things up into trivial components that are, you know, easy to test, or at least help kind of isolate the harder, more difficult things and make those testable, so that when you do the integration is done in a trivial way, so that you're more confident that like the code is correct. So we'll kind of end here. For those of you guys who are still working on these things, you know, feel free over the next few days, work on them, and perhaps we can use that Slack channel as a way of discussing different alternatives, and you can share, and we might be able to chime in and basically share your solutions there, or put them in the spreadsheet and ask people to take a look, and we can use it as an opportunity over the next day to kind of just discuss them on Slack. But yeah, thank you everyone for participating. For those of you who are still around, sorry for cutting into the break. Let us know if you found this in any way useful or insightful. You can kind of direct message me or James on Slack. And if you have any suggestions for how to do this in a remote way in the future. But yeah, thank you guys all for participating, and yeah, enjoy the rest of the conference.